Before we begin our discussion of blood types, let's review what we know about blood. According to the textbooks, about half of the volume of blood is made up of blood cells that begin as stem cells in bone marrow. And these stem cells can develop into any of the other kinds of cells found in blood, including red cells, white cells, and platelets. So, some stem cells become white cells, and these are essential to the immune system. And when bacteria or germs invade the body, some of the white cells form antibodies to resist the infection directly, while other white cells begin to work on the chemistry of the foreign substance itself to fight the infection. Now, compared with red blood cells, there are relatively few white blood cells, only about 1 for every 700 red cells, and the smallest of the blood cells are called platelets. But what they don't have in size, they make up for in numbers. Well, most of us have about 2 trillion of them, and they work to help the blood to clot and repair holes in the walls of blood vessels. But we need a way to transport the blood, right? Plasma is the liquid substance in blood that transports most of the chemicals, vitamins and minerals, hormones and enzymes. But most stem cells become red blood cells. They are the most numerous. As I mentioned before, there are about 700 to every 1 white blood cell. So the red cells give blood the color red, and they are important for what we call blood typing. And blood typing is what I want to get going on today. Now, blood types are a classification of red blood cells according to the presence of specific substances, antigenic proteins, and carbohydrates. And you can see them under the microscope on the surface of the cells. The 4 blood types are identified by letters A, B, AB, and O. Blood type A contains red blood cells with the antigen A. Blood type B contains red blood cells with the antigen B. The AB blood type contains both antigens, and the O blood type contains no antigens. But the individual with this type can form antibodies containing either A or B antigens.
Excuse me, is that why the O blood type is considered a universal blood type? Because it can form antibodies with either A or B antigens?
Right you are. But in typing the blood, the antigens are really much more complex than this explanation might suggest. There are at least 300 different antigens. In fact, there are so many potential combinations that an individual's blood type is almost as unique as a fingerprint. But anyway, these basic types are used for determining compatibilities for blood transfusions. Before a transfusion is approved, hospitals always perform a procedure called a cross-match, which involves taking a sample of the donor's red blood cells and mixing them with a sample of the patient's plasma. You see, in almost every individual, the plasma contains antibodies that will react to antigens that are not found on their own red blood cells. So during a transfusion, antibodies in the patient's plasma can bind to antigens on the donor's red blood cells when the donor's blood is not similar to that of the patient. Well, many minor reactions can occur like fever or chills, but some reactions are so severe that they lead to a spontaneous destruction of the red blood cells from the donor, and that can result in shock or even death. So, you can understand why blood typing is so important. Cross-matching lowers the risk of a serious reaction. Okay, in cross-matching, we take red cells from one person and plasma from the other person, and we watch to see whether there is a negative response. Well, of course, doctors prefer to use the same type as that of the patient, but compromises have to be made in emergencies. Type A patients can receive type B blood, and type B patients can't receive type A blood. But, back to your question, since an O donor has blood that's compatible with both A and B antigens, it is the ideal, or as you said, the universal donor. In an emergency, type O blood can be used for patients of all blood types, and fortunately, worldwide, type O is the most common, followed by type A. Relatively few people have type B blood, and the fewest have type AB.
Professor, can you tell us anything about artificial blood?
Well, actually, scientists developed artificial blood that's been used successfully in blood transfusions with human patients. It is a white fluid chemically similar to Teflon, the material that coats cookware and prevents material from adhering to it. The fluid can be used as a match with all blood types, and so the cross-matching step in transfusions that can be eliminated.